A flat board has a circular hole with radius 1 and a circular hole with radius 2, such that the distance between the centers of the two holes is 7. Two spheres with equal radii sit in the two holes, such that the spheres are tangent to each other. The square of the radius of the spheres is m over n, where m and n are relatively prime positive integers. Find m plus n. Okay, so we need to understand like the geometry that's going on here. The fact that the two spheres have equal radii, but because the holes they're sitting in also have different radii, they will sit at different heights. So as seen from above, there's a hole of radius 1 and a hole of radius 2. And the distance between these is 7. So that means, of course, that this distance here is 4. So that's as seen from above. Now, when we look at it from the side, there's my hole of radius 1. There's my hole of radius 2. If I put two spheres inside these holes and they have the same radius, then this sphere will sit up higher. This is a terrible drawing. And this one will fall down lower into the hole. Yeah. How about instead I do this? Okay, so there's a circle. I'm going to copy it and just move it down a little bit, make them tangent. Okay. Maybe I should move it up a little bit like that. Okay, and now if I draw a straight line that represents the board itself, something like that. So that's a distance of 1. That's a distance of 2. The distance between them is 7. And each of these has the same radius, which we'll call capital R. Okay. So of course, the distance between the centers of the spheres is 2r. This distance is 7. That's r minus 2. That's r minus 1. And I would love to write down an equation where I can solve for r. Um, so that means that this distance here, that's 1, right? I think. No, maybe not. Hold on. Yeah, I think I said something earlier about what this distance is or what that distance is, and it didn't make any sense because I don't know what this height is. Although that's r. Call this h. So I have r squared is equal to h squared plus 4. And if I call this larger height, if I call this here h prime, then I have r squared is equal to h plus h prime squared plus 1. That's just Pythagoras on that triangle. And then I also have, if I do Pythagoras on this triangle, I have 2r squared is equal to h prime squared plus 49. So I have 3 equations and 3 unknowns. I don't need to solve for anything. I don't need to solve for everything. I need to solve for r squared. What I'm going to do is I'm going to expand this equation. Oh, but then I have this h prime, which is pretty messy. I was going to substitute for h squared and h prime squared, leave things only in terms of r squared. But the h prime is well, what if I rearrange that? Okay, yeah, I'm going to substitute for h squared and h prime squared here using this equation and this equation. So h squared is equal to r squared minus 4, and h prime squared is equal to 4r squared minus 49. So here r squared is equal to h squared plus 2h h prime plus h prime squared plus 1. Okay. So we've got that. I'm tempted to square this and then make substitutions again for these things. Oh, we get some cancellations of r to the 4. That'll be helpful. I think I did the arithmetic there correctly, although except for 26 squared, which is what? $676. So I've got 676 minus 104 r squared plus 49 r squared plus 16 r squared minus 196 is equal to 0. Okay. 676 minus 196. $480. So 480 is equal to 104r squared minus 65 r squared. $99 minus 60, $39. I think these are both divisible by 3. 480 divided by 3 160 over 13. Does this geometrically make sense? This is greater than 10. Oh, r squared is greater than 10. So r will be between 3 and 4. That seems reasonable. Yeah, so I get 173 as the answer here, the numerator plus denominator. I'm fairly confident that I've set this problem up in a way that leads it to being solved. I basically have three variables, capital R, H, and H prime. And I have three triangles where I can write down a Pythagorean theorem for that, a Pythagorean theorem for that, and a Pythagorean theorem for that. So that's three equations, three unknowns, in theory can be solved. And as long as I did the arithmetic and algebra and stuff like that correct, this should be the right answer. I'm not going to go back and try and find a mistake, but when I check the solution to this problem, if there's an error, then I'll let you know that I have the wrong answer. But I'm not going to find exactly where my answer is incorrect if it happens to be. I hope it's right, of course. Thanks for watching.